Let's look at this problem. We have a curve, this curve, and the question is about the area that is bounded by this curve, and we want that to be expressed in this format: m plus n pi, where n and m are integers, and it's asking about m plus n. Alright, so obviously this is an analytical geometry problem, and the hard part of this is to comprehend or to imagine what exactly the shape of this looks like. Once we get that shape, then we have many tools to calculate the area. Therefore, first of all, we have to draw this diagram. But even before that, we need to do one more thing, because on the right hand side of this equation, we have some absolute values. In order to transform this to some standard analytical format, we have to expand these absolute signs. Okay, let's see how do we do that. So first of all, we want to expand the absolute signs, right? Therefore, we have to do the casework. We have to expand the two absolute signs one by one, and then consider the different combinations. So in the first case, we have x minus y greater than 0 and x plus y greater than 0, greater than or equal to 0. And at this time, the equation of this curve becomes x squared plus y squared equals, now we can remove the absolute sign directly, right? So that's 3 times x minus y plus 3 times x plus y. And then let's collect the terms and simplify the expression. So we have 3x, that's 6x. And that's minus y, this is plus y. Therefore, the y terms cancels out. Then let's rewrite this as a standard format. So this is x minus 3 squared plus y squared equals 9. And let's rewrite this as 3 squared. Therefore, we recognize this format is a standard form of a circle on the plane. As a reminder, we know that the general format of a circle looks like this: x minus a squared plus y minus b squared equals r squared, where a and b is the origin of the circle, a, b. This point is the origin, and the radius is r, right? And now let's look at the second case. In the second case, let's still assume that x minus y is still greater than or equal to 0, and x plus y is less than 0. And then the original expression can be written as x squared plus y squared equals 3 times x minus y, and minus, because the second term is a negative value, right? So we need to add a negative sign when we remove the absolute sign. So that's a minus 3 times x plus y. Now let's collect the terms. So we have a 3x and a minus 3x. Therefore, the x terms cancels out. We have a minus 3y and another minus 3y. So that's minus 6y. Now let's rewrite this in the standard circle format. X squared plus y plus 3 squared equals 3 squared. Then let's look at the third case. In the third case, let's assume the inner part of the first absolute value is less than 0. So that is x minus y less than 0. And the second part is greater than 0. X plus y is greater than or equal to 0. So the curve becomes x squared plus y squared equals minus 3 times x minus y, right? Because the inner part is negative value, so we have to add a negative sign. So that plus 3 times x plus y, which equals So the x terms cancels out, and we have 6y. Therefore, this equation can be written as x squared plus y minus 3 squared equals 3 squared. So let's scroll down a little bit. The last case is the first term is less than 0 and the second term is also less than 0. And then the curve becomes x squared plus y squared equals minus 3 times x minus y minus 3 times x plus y. And this equals negative 6 times x. And the whole equation can be rewritten as x plus 3 squared plus y squared equals 3 squared. Alright, so now we are done with the handling of the absolute values. Let's draw the diagram. So let's say this is our coordinates, x, and this is y-axis. Good. Before we draw the curves, we have to do one more thing. This is because we have 4 cases which split the whole curve into different parts. Within each part, we have a standard analytical format. Therefore, we have to cut the plane into 4 parts first. Okay, then how do we cut the plane into 4 parts? That is exactly by these equations, right? And we know that each equation is actually a combination of 2 lines. So let's draw these 2 lines. So certainly one is x minus y equals 0. That line is like this. So this is one line. And this is x minus y equals 0. And the other line is x plus y equals 0. So that should look like this. It also passes the origin and going from the bottom right to the upper left. Okay, so now let's examine each subcase individually. So for case 1, since we have x minus y greater than or equal to 0, and that represents this part, I'll use some light lines to represent this. That is like this, right? And for x plus y greater than or equal to 0, that is this part, right? That is this part. Good. Therefore, we know that the first case must be within this range. This is 1. And I'll use a pink color to give you a clear idea of this part. So that is this part. On the right hand side of the entire plane, and which consists of the positive part of x-axis. And now let's look at the curve. The curve is this. Certainly this is a circle, but it's only part of the circle, because it's a circle that drops within this range, this pink range. And we know that the origin of this circle is 3 and 0. So let's say this is 3. So that is the center of this curve. Then let's draw a line perpendicular to the x-axis. And the circle will be just like this. That is the half circle in this part, right? And the rest of the circle goes like this. But since it goes out of our range, so we have to discard the other half of it. So this is case 1. And for case 2, let's use a different color as well. Let's use this blue. So the second curve is this, right? So that's a circle with a center at 0 and -3. So that's here. Let's say this is -3. And we also draw a line like this. Remember, these lines will connect. This is a closed figure. Remember, this is 45 degrees, this is 45 degrees. And each of these angles are 45 degrees. Therefore, the second circle will start right at here, where it joins the first part of the circle. So the second part of the circle is just like this. And again, this is only half of the circle that satisfies this range. Good. And by symmetry, we can draw the other two parts easily, right? So I'll just draw them quickly. So I'll still use the original color. So here is 3, and this is the diameter. And the circle in this part is like this. And this is -3. And we can draw a diameter like this. Remember, this is not a perfect picture, so this is not a perfect picture. Actually, they do form an enclosed area. So this is like this. Good. Therefore, the full picture of this curve looks like a kind of a flower, right? And the area of this enclosed part is actually very easy to calculate, because if we connect these lines, we know that the center part is actually a square with a side of 6. And then we have 4 semicircles. Therefore, the area equals this. This is the total area of the enclosed part. That equals the area of the center square plus 4 times the area of half circles, right? Which equals 6 square plus 4 times half circles, right? It's a half times pi and r squared. What is the radius of each of these semicircles? That is 3, right? That's 3. So that's a 3 square. Therefore, this equals 36 plus, let's cancel the 4 with 2. We have a 2. 2 times 3 square. That's 18 times pi. Therefore, our desired area is this. And now let's look at the choices. So we want the final answer to be written in this format, right? Remember, that number is 36 plus 18 times pi. Let's confirm that, right? This is our answer. And we want to select a choice that gives m plus n. M is 36, n is 18. So 36 plus 18, that is 54. Therefore, E is our choice. If you like this video, please give it a like and subscribe the channel. If you have questions, please leave a comment.